Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 11.3. The table below includes results from a polygraph experiment conducted by researchers. In each case, it was known if the subject lied or did not lie. So the table indicates when the polygraph test was correct. Use a 0.05 significance level to test the claim that whether a subject lies is independent of the polygraph test indication. And then there's a follow-up question that asks, do the results suggest that polygraphs are effective in distinguishing between truth and lies? Before we look at the table, we can determine the null and alternative hypotheses by realizing that this is a test for independence, and independence will always occur in the null hypothesis. So saying the test is accurate or not accurate is irrelevant of this particular hypothesis test, and the test for independence or the claim of independence will always fall in the null hypothesis portion. So the answer should be C. As we try to determine the test statistic, we will need to look at the actual summary data. And here is the table. We will just copy the table onto a clipboard and paste it onto our Google Sheets. Now, the formula that we need for the test statistic is this O minus E quantity squared divided by E and the sum of that. And all we have right now are the observed values. So what I would like to do is maybe call this O for observed, or maybe just say OBS. And then down here we want to get an expected value. But we would need to capture that same table, or at least the same row and columns for the table. So let's copy this, and I will paste it down just a couple of rows below, and then here we will capture our expected values, and then these numbers are going to change in here in the body of the table, but we'll do that change according to the formula that says each expected value will be the row total times the column total divided by the grand total, which means we need row, column, and grand totals for the original table. And then we will compute the test statistic by looking at this O minus E quantity squared divided by E. So again, we will change these values accordingly. So we can clear all that for now. This one, we can also clear all this for now. And then we'll focus on the column totals, the row totals, and the grand total. So let's compute the column totals by typing equals, and then SUM will highlight the things that we wanted to add. Now we're also adding this row, so we can do the same thing for the second row. And then we can actually do the same thing for the third row, but instead we'll add up the columns. So again, we'll say SUM equals SUM, and then we'll highlight those rows or those cells, and then we'll click and drag to get the column totals. Now the row total or the grand total is going to be the sum of everything, so we can just say equals. We can also just add up the column total or the row total, but not both. So the grand total should be 72. Okay, so now that we have the column, row, And the grand totals, let's find the expected value. So the expected value for each cell will correspond to a cell in the original table, and we will compute the row total, the column total, and the grand total. So we'll say equals, we'll click on the row total. This is for the number 9 here in the 9 slot. So that's a 44 times the column total, that's 29, divided by the grand total, which is 72. Okay, let's continue doing the same thing here. Equals, this is still the first row, and this time it's a second column, and then we'll divide by the grand total. Okay, on to the second row. So this will represent the 20. We'll say equals, and the row total for that is 28 times the column total is 29 divided by 72. And then the second row, second column will be the 28 times the 43 divided by the 72. So these are the expected values here. Okay, so now for each one of these cells, we want to combine the observed values minus the expected value. We'll square that and divide by the expected value. So that's the formula. Oops, that's the formula for the test statistic. At least that's the formula for each of these cells, and then we're going to add them all up. Okay, so we'll say equals. It's going to start with a parentheses, the observed value minus the expected value, close the parentheses, square that, and then divide by the expected value again. Alright, now the nice thing about this is that since we're looking at these values according to the rows and columns, this is the opportunity where we can click and drag, and then now each of these cells in this third table will have these quantities O minus E squared divided by E. And according to our formula, we're going to add up all those values to get our test statistic. So let's just mark it here, test statistic. And then this is going to be the sum of all these values that we just found. So our test statistic should be 18.483. Okay. Let's try that. 18.483. Okay. To find our p-value, remember this is a chi-square test. And it's a chi-square test that it's always going to be right-tailed. So what we need to do is we need our degrees of freedom. Our degrees of freedom is the number of rows minus 1, the number of columns minus 1. So there's 2 rows, 2 columns, so our degrees of freedom here, let's just call it df, and that's going to equal to 2 rows minus 1, so that's 1 times, and then 2 columns minus 1, so that's 1 again. So our degrees of freedom is just going to be 1. Okay, so down here our p-value is going to be equal to the chi-square distribution, that's CHISQ dot DIST, and this is a right-tailed test, so we will say dot RT. So that's chi-square distribution. It takes in 2 values. It takes in the test statistic, comma, and then it takes in the degrees of freedom. And then we press enter, we get something that's really, really small, and we have more than 4. We have 4 zeros and then a 17, so this is going to be essentially 0 if we round this off to 4 decimal places. Okay. So now that it's 0, we are going to reject the null hypothesis. So it doesn't give us the option to reject the null hypothesis, but as we reject the null hypothesis, we're going to reject the claim that the row variable and the column variables are independent. So there's sufficient evidence to warrant the rejection of the claim that whether a subject lies is independent, so that's the claim, it's independent of the polygraph test indication, and we were able to reject that. Okay, so it seems like it's not independent of whether they lie, so it seems like maybe this polygraph is not so effective after all. Okay, I hope that helps.